All right, so number one, we are given that the measure of angle 1 equals the measure of angle 3. These are corresponding angles. We do need to say that the corresponding angles are congruent by the definition of congruence. And then we can say the lines are parallel. And when we're proving lines parallel, it's always the converse of the theorem or postulate that we're using. So it's the converse of the corresponding angles postulate. Number two, we're still using the same figure. We are given the measure of angle 7 and angle 5, which angle 7 and angle 5, if we look on the figure, are corresponding angles. So let's show that these corresponding angles are congruent. We're also given the value of x, which is 13. So I wrote down my given. Then what I'm going to do is I'm going to use substitution to take this 13 and put it in for x in both the measure angle 7 and angle 5. I'm not going to simplify yet because that's a separate step. So using substitution, I get this, and then I can simplify. And I see that both of them are equal to 77, so either by substitution or the transitive property of equality, I can set the measures equal to one another. But then I need to say that they're congruent by the definition of congruence. And since I have corresponding angles congruent, I can then conclude that my lines are parallel by the converse of the corresponding angles postulate. All right, this time I am given lines P and M are parallel, and angle 1 and angle 3 are congruent. And I want to prove that lines R and N are parallel. So I'm going to state my given. Looking at these two parallel lines, cut by this transversal, angle 1 and angle 2 are corresponding angles, and since we have parallel lines, by the corresponding angles postulate, I can say that those angles are congruent. Since I know angle 1 is both congruent to angle 3 and angle 2, I can then use the transitive property of congruency. I cannot use substitution. Transitive property of congruency to say angle 2 and angle 3 are congruent. And if angle 2 and angle 3 are congruent, I can then say that lines R and N are parallel because angles 2 and 3 are alternate exterior angles. And so by the converse of the alternate exterior angles theorem, I can conclude that I have parallel lines. Moving on to the next page. This one's a little bit of a longer one, so bear with me. I'm given angle 1 and angle 4 are congruent. And I'm given angle 3 and 4 are supplementary. And I want to prove that lines P and M are parallel. So I'm going to state my given. And now I'm going to use the information that angles 2 and 3 are vertical angles. They're right across from one another, so they are congruent by the vertical angles theorem. Now, in order for us to use the statement that angle 3 and 4 are supplementary, we're going to need to convert all these things into the measures being equal. So the measure of angle 1 is equal to the measure of angle 4, and the measure of angle 2 is equal to the measure of angle 3. That's the definition of congruence. So then, using this step, angle 3 and angle 4 are supplementary, I can say that the measure of angle 3 plus the measure of angle 4 equals 180 degrees. Now, in order to prove that P and M are parallel, I would want to prove that angle 1 and angle 2 are supplementary, or that they add up to 180. And right now I cannot do that. However, what I can do is I can take, knowing that the measure of angle 2 is equal to the measure of angle 3, I can take the measure of angle 2 and substitute it in for the measure of angle 3 here. Oh, it looks like I did the opposite, but you can do it that way too. What I did was I took the measure of angle 1, knowing that it's equal to the measure of angle 4, and I substituted it in for the measure of angle 4 to get the measure of angle 3 plus the measure of angle 1 equals 180. Then what I did was I took the measure of angle 2, since it equals the measure of angle 3, and I put it in for the measure of angle 3 here, using substitution. And now that I know angle 1 and angle 2 are supplementary, or they sum to 180, and since they're same side interior angles, I can then conclude lines P and M are parallel by the converse of the same side interior angles theorem. Great. Looking at my next one, I am given the measure of angle 2 and 3 added together equal 180. And I want to prove that lines P and M are parallel. So I can use the vertical angles theorem to state that 3 and 6 are congruent. And then if I'm trying to use these two in conjunction with one another, I need to change the measure of angle 3 equal to the measure of angle 6 using the definition of congruence. And then what I can do is I can take the measure of angle 6 and substitute it in for the measure of angle 3. Because what that is going to do is that's going to show that these same side interior angles are supplementary. So I'm just doing substitution. And so since these same sides interior angles are supplementary, I can say that the lines are parallel by the converse of the same side interior angles theorem. And there's other ways that you guys can be doing these proofs. These are just some examples. Like for example, number 6 has a lot of different ways that you can go about this proof. And I'm just giving you one example of it. So I know that A and B are parallel and L and M are parallel, and I'm just trying to prove that angle 1 is congruent to angle 13. So that's these two angles. And so I'm going to use things that I know about these two angles, or pairs of angles in relation to these two angles, that can help me figure out how to get angle 1 and angle 3 congruent, or angle 1 and angle 13 congruent to each other. So I state my given. I then know all lines are parallel, so I can say angle 5 and angle 13 are congruent by the corresponding angles postulate. I can also say that angle 1 and angle 5 are congruent by the alternate exterior angles theorem. And since I know that both angle 1 and angle 13 are congruent to the same angle, then I can set them congruent to each other by the transitive property of congruency. I cannot use substitution in this case because of the congruent symbol. Now, this is not the only way that you could go about it. You could have also went with saying angle 1 and angle 3 were congruent by corresponding angles theorem, and angle 3 and angle 13 were congruent by alternate exterior angles theorem, and then went to the transitive property. That would have been acceptable as well. So number 7 is fixed on your end. We want to prove that the measure of angle Z equals the measure of angle X plus the measure of angle Y. So we're going to state what's given to us. We are given that AB is parallel to CD. And then we are going to draw in an auxiliary line to help us with this. And when we do draw an auxiliary line in, we need to label that auxiliary line. I'm going to label it EF. And the purpose of this auxiliary line is to aid in the proof. And I want EF to be both parallel to AB and CD to help me with the proof. Now, when we do an auxiliary line, we need to state it in our proof. And we state what we know about the auxiliary line in the statements column. And your reason is we drew in that auxiliary line. So what I know about my auxiliary line, or what I made it to be, is I made it to be parallel to AB and CD. So I wrote that here. And my reasoning is I drew that auxiliary line in to help me aid in this proof. Now you can add variables. You don't have to name or say that you added variables. I'm splitting angle Z up into angle A and angle B. You could use different variables to help you. But if I look at these two parallel lines here, oops, let me outline them. If I look at these two parallel lines, cut by this transversal, angle X and angle A are congruent because they're corresponding angles. If I look at these two parallel lines, cut by this transversal, angle Y and angle B are congruent because they're corresponding angles as well. So since they have the same reasoning, I can put that in one step. But before I do, I'm going to use the angle addition postulate to say that the measure of angle Z is equal to the measure of angle A plus the measure of angle B. And then, like I said, I'm using the corresponding angles postulate to say angle X is congruent to angle A and angle Y is congruent to angle B. But in order to use steps 3 and 4 in conjunction with one another, I need to use the definition of congruence to state that the measure of angle X equals the measure of angle A and the measure of angle Y equals the measure of angle B. Now I have enough to take the measure of angle X and substitute it in for the measure of angle A and the measure of angle Y and substitute it in for the measure of angle B to get what I'm trying to prove, the measure of angle Z equals the measure of angle X plus the measure of angle Y. That was by substitution. So I encourage you to look back at these proofs and maybe the ones that were more challenging for you, write them down on a separate sheet of paper and try them again until you get the process behind each of these proofs. Proofs are tough, and so we need to practice them. Without the practice, we're not going to get good at them. And a way to practice is to make sure that you practice similar types of proofs or even the same proof over and over again until you completely 100% understand the sequence of the steps and the logic behind the reasons. All right, that brings us to the end of our GCO 9 standard.